Now we can learn Polish faster than ever before, thanks to AI Polish.
So when most of us think about learning a new language, in L2, our minds immediately go to flashcards,
Right.
vocabulary lists, verb charts. It feels like you're just cramming for a huge test.
It's that traditional model, and it treats the brain like this empty hard drive you just have to fill up with files.
Exactly. And it's why so many people get frustrated and just quit.
Yeah.
But the sources we looked at for this deep dive, and this is stuff coming out of, serious neuroscience and neurolinguistics, they tell a totally different story.
A much more interesting one.
Way more.
Yeah?
The central idea, the big takeaway, is that mastering a second language isn't just a memory game. It's an act of, and I'm quoting here, directed biological and structural modification.
It sounds intense, but that's what's happening. You are physically rebuilding parts of your brain.
So our mission today is really to unpack that, to look at the actual blueprint for how your brain changes. Because if you understand the biology, that becomes the ultimate shortcut, right? It helps you pick learning methods that actually work with your brain, not against it.
That's the core insight. Yeah. L2 acquisition is this huge cognitive undertaking. So if you're going to put in the hours, you want to be smart about it. And the best methods are the ones that line up with how the brain is built to function. I'm talking about principles like plasticity, optimized memory encoding, and its specialized neural architecture.
Okay, so let's dig into that foundational claim. The sources say learning a new language isn't like adding a new skill, like learning to juggle. On a biological level, what is going on?
It's a fundamental structural change. The learning process, if it's done right, actively transforms your brain's structure.
It transforms it.
Yes, and that sets up what we can call the neuroscientific imperative. L2 success is about achieving that biological change. If your learning method isn't demanding enough to kickstart that transformation, well, mastery is just going to stay out of reach.
That sounds incredibly demanding, but it's also really hopeful in a way. And the key concept that explains how this is even possible, especially in adults, is neuroplasticity. We hear that word thrown around a lot. How do the sources define its role here specifically?
So neuroplasticity is just the brain's built-in ability to reorganize itself, to form new neural connections and get rid of old ones that aren't being used. It's happening throughout your entire life.
So it's not just something that happens when you're a kid?
Exactly. The sources are really clear on this. While some types of learning are easier when you're young, the kind of high-effort structural plasticity you need for language learning, that capacity stays with you, even into old age.
The capacity is there.
Okay.
But what flicks the switch? What's the trigger? Like if I'm just listening to a podcast in French while I do the dishes, is that enough to start this big reorganization?
It's a start, but no. That's passive exposure, and you need that for input, but it's not the trigger.
So what is?
Active engagement. High demand scenarios. The physical restructuring process gets activated when you are forced to grapple with something, like trying to understand a really complex sentence, or when you're trying to express a nuanced idea yourself and you're searching for the words and the right structure. That whole process requires intense problem-solving, attention, and an enhanced working memory.
So you're basically giving your brain a problem that it wasn't originally wired to solve. And that cognitive strain is what tells it, okay, time to build something new here.
That's it exactly. It's like putting enough stress on a muscle that it has to grow stronger to handle the load next time. You're forcing your neural circuits to reorganize.
Okay, this is where it gets really interesting, where we move from the theory to the physical proof. If the brain is really doing all this high-effort work, reorganizing itself, what can neuroscientists actually see? What are the tangible results?
This is the amazing part. You can see it on brain scans. The restructuring leads to measurable physical changes. And the sources point to two main transformations that are directly linked to how proficient you become in a second language.
Okay, what are they?
First, you get measurable increases in gray matter density.
Gray matter, that's the processing part of the brain, right?
Primarily, yes. It's mostly the neuronal cell bodies. And in L2 learners, you see this density increase in really critical language areas, like the left inferior parietal cortex.
So if the brain is a computer, increasing gray matter is like, what, upgrading the processor?
Yeah.
Giving it more raw power?
That's a really good analogy, yeah. It's giving you more processing power to handle things like new sounds, complex grammar, abstract words. But power isn't everything. You also need good connections.
Ah, which brings us to the second change.
Exactly. The second key change is an enhancement in white matter connectivity.
And white matter is the wiring? The brain's internal internet. Is this like upgrading from dial-up to fiber optic?
Precisely. It's the myelinated axons, the long-range cables connecting different brain regions. Better white matter means faster, more efficient signals between all the different parts that handle language.
So connecting the part that hears the word to the part that understands its meaning to the part that tells your mouth how to say it.
All of that. It makes the whole network faster and more seamless.
That is just,
Yeah.
it's profound. It means that someone who's really fluent in another language hasn't just memorized more stuff. They've physically built a better, faster brain for using that language.
That's absolutely the implication. And it validates this whole idea of high-effort learning, the struggle, the mental work. That's what it takes to kick off this physical remodeling process. Your brain is literally sculpting itself based on what you ask it to do.
You know, this completely changes how you should think about that feeling of struggle. That mental fatigue you get when you're wrestling with a difficult concept in your target language. It's not just you being tired, it's the feeling of construction. It's a sign that you're actually building a stronger brain.
It's a sign that it's working.
Okay, so let's shift from the what and the why to the how.
Yeah.
This is the part that everyone wants to know. If success means physically changing our brains, growing gray matter, strengthening white matter, how do we do that on purpose?
We have to change our whole approach, move away from just passive consumption and toward optimized neural engagement. Meaning we need to pick learning methods that are designed to create that high cognitive demand we talked about, the demand that triggers plasticity. And the sources show that to really do this right, learners need to engage cognitive mechanisms across 3 critical domains.
The 3 pillars of optimization. And these come from just general neuroscience research on how we learn and remember things, right?
That's right. These aren't language learning tricks. They are fundamental principles of how the brain builds lasting knowledge.
Okay, let's break them down. What's the first pillar?
The first is retrieval practice.
Okay, what's that?
It's the act of forcing your brain to actively recall information from memory without looking at your notes. It's basically testing yourself.
So not just rereading a vocabulary list.
Exactly. Rereading just leads to recognition. Oh yeah, I've seen that word. But retrieval is, what was that word for? Every time you successfully pull that information out of your memory, you strengthen the neural pathway to it. You're paving that white matter highway.
So things like using flashcards where you force yourself to say the answer before you flip it over.
Yeah.
Or trying to form a sentence from scratch.
Perfect examples. The second pillar is spaced repetition and interleaving.
I've heard of spaced repetition. That's about timing your reviews, right?
Our brains forget things over time on a predictable curve. These structural changes we're making, they need time to consolidate, which happens a lot during rest and sleep. Spaced repetition systems have you review information right before you're about to forget it, which is the most efficient moment to strengthen that connection.
And what's interleaving?
That's mixing things up. So instead of practicing 1 grammar point for an hour, you practice 3 different ones, switching between them. It feels harder.
I bet it does.
It feels much harder, but it forces your brain to be more flexible, to constantly retrieve different rules and patterns, which prevents it from just going on autopilot. It keeps that plasticity trigger engaged.
Okay, so we have retrieval and we have spacing. What's the third pillar?
The third is deep contextual encoding.
Sounds complicated.
It just means learning things in a rich, meaningful context.
Mm-hmm.
To really grow that gray matter density, the information needs to be integrated. Learning a word from an isolated list is very shallow.
Low context.
Very low context. But learning that same word as part of a story, or in an emotional conversation, or by reading a complex article where its meaning is crucial, that demands way more from your brain.
Because your brain has to connect everything, the sound, the spelling, the grammar, the emotion, the cultural nuance.
Exactly. And when it has to juggle all of that, it has to dedicate more processing power. It has to invest more neural resources.
And that investment is the gray matter growth.
That is what drives density.
Right.
So effective methods have to be based on authentic, meaningful communication, not just drilling isolated facts.
So if you put it all together, we can basically stop chasing every new app or fad. We just need to ask if a method is built on these 3 pillars. Does it force me to retrieve information? Does it space out my practice? And does it put everything in a deep, meaningful context?
If the answer is yes to all 3, you are aligning your efforts directly with your brain's biological blueprint for change.
This has been a really fantastic deep dive. I think the major takeaway is so clear. Language learning isn't just about collecting facts. It is an act of neurobiological remodeling. You are tangibly increasing your gray matter density and improving your white matter connectivity.
And understanding that biology, knowing about neurology and neuroscience, it gives you an expert guide. It lets you look at any learning method and know if it's designed for real, lasting success. If what you're doing doesn't feel challenging, if it doesn't force you to actively problem solve, it's probably not using your brain's incredible capacity for change.
Which leaves us with a final, provocative thought for you to consider. We've established that L2 acquisition works by activating neuroplasticity through intense demands on problem-solving and working memory. So think about this. Is the best way to keep your mind sharp and flexible as you age simply to never stop tackling a challenging new language? Maybe the struggle to learn a new language isn't just about being able to travel and talk to new people. Maybe it's the ultimate form of preventative brain maintenance.
Now we can learn Polish faster than ever before, thanks to AI Polish.